Alright, guys. I'm gonna say this once, because I've said it once. That makes sense. Alright, I'm telling you right now, I will master organic chemistry. Alright? I will master organic chemistry. If it's the last thing I do, I'm gonna master organic chemistry. Because I'm sick and tired of being an organic chemistry noob. Alright? I'm sick and tired of it. Right now I'm trying to figure out my microphone settings because I don't know what's going on. But yeah. I don't know what's going on right now, but yeah. Hopefully we should be good. Alright. Give me a second. Oh wait, my phone's here. I'm gonna see how my mic quality is. I'm gonna see how my mic quality is from here. And yeah. She gonna call me baby boo. My bad. Holy crud, the internet is so bad. I probably shouldn't be streaming on 2 different platforms. Alright. Holy crud, the delay is so bad. Holy crud, the internet is so bad. Actually, it's not that bad.
I probably shouldn't be streaming on
which is a 6-carbon alkene. How can we convert this into a skeletal structure? So this structure is equivalent to what I'm about to draw here. I'm going to expand it. Notice that we have 4 CH2.
Holy crud, the delay is so bad.
We're going to talk about how to convert condensed structures.
Holy crud,
so we have a total of 6 carbon atoms in a straight chain.
Okay, what's going on?
In order to convert this into a skeletal structure, we need to draw lines. This one line represents 2 carbon. This is a carbon, and this is a carbon. So lines have 4 CH2s, or 4 methylene groups. So we have a total of 6 carbon atoms in a straight chain. In order to convert this into a skeletal structure, we need to draw lines.
Hello.
This one line represents 2 carbon. This is a carbon, and this is a carbon. So this would be the CH3 carbon, and this would be the CH2 carbon. This will be the 3rd carbon, the 4th one, the 5th, and the 6th carbon. So that's hexane as a skeletal structure. Now let's work on another example. Let's say we have CH3 times 2, and then we have a CH, and then 2 CH2s and a CH3. How would you convert this condensed structure into a skeletal structure? Now, if you want to pause the video, feel free to do so. Now, what I recommend doing for this example is to expand the structure first, and then convert it into a skeletal structure. So let's start with the CH carbon. So this carbon is attached to 2 methyl groups. A CH. Here's the first one. Here's the second one. And then 2 CH2s and a CH. Now that carbon is attached to 2 methylene groups. Into a skeletal structure. And then a CH3. Now we do have a hydrogen here. So that's the expanded form of this condensed structure. Now let's convert it into a line structure. The reason why we want to do this first is so that we can identify the longest chain, which is here. 1, 2, 3, 4, 5. So this is 2, 3, 4, 5. On carbon 2, we have a methyl group, so we'll put that there. And this is our answer, 2-methyl-pentane. So that's how we can convert this condensed structure into a skeletal structure. Try this again. CH3 times 3, and then a carbon, and then CH, and then CH2. Convert that.
Live.
So first I'm going to expand it. Let's start with the carbon atom. So that carbon is attached to 3 methyl groups. Here's the first one. Here's the second one. And here's the third one.
Live.
Now that carbon is attached to a CH.
Live.
So here is the CH, and here is the CH2 carbon. Notice that this carbon has 3 bonds in the CH2, even though we've already included all of the hydrogen atoms. Carbon likes to form 4 bonds, and there's no indication of a positive or negative charge here. Try this example. CH3 times 3, and then a carbon.
Is this good?
And CH2.
This is good.
Convert that into a skeletal structure.
Alright.
So first I'm going to expand it. Let's start with the carbon atom. So that carbon is attached to 3 methyl groups. Here's the first one, here's the second one, and here is the third one. Now that carbon is attached to a CH and a CH2. So here is the CH carbon, and here is the CH2 carbon. Notice that this carbon has 3 bonds, and the same is true for that carbon, even though we've already included all of the hydrogen atoms. Carbon likes to form 4 bonds, and there's no indication of a positive or negative charge here. That's the only time carbon has 3 bonds, is when it has a plus or minus charge. But when it's neutral, typically it wants 4 bonds. The only way to have 4 bonds is to put a double bond here. Now both carbons will have 4 bonds. So now let's convert this into a line structure. So let's identify the longest chain, which is 4 carbons. So 2, 3, 4. We have a double bond between a between carbons 1 and 2, and on carbon 3 we have 2 methyl groups. We've already incorporated that one. So we can show the 2 methyl groups like this.
Okay, so you can 2, 3, 4. 1 and 2 has a double bond. 1 and 2 has a double bond. Then you can go like this.
So
Okay.
this is the answer. 3,3 dimethyl 1-butene. Now this is for those of you who want access to the extended version of many of my organic chemistry videos that you see on YouTube. So you can have this completed. Here's the 4. Now let's try a longer one. CH3, 2, CH, CH, Br, CH2, CH3. So feel free to try.
Alright. Three, 4. Alright, so we got 1 CH3, another CH3, CH. Yo. Alright, also I'm not going to be engaging with the chat, so, because I need to walk in. Because I will master organic chemistry. I promise you. Yeah, that makes sense. CH. I should get a hand cam. That would be smart. That's not that bad of an idea. How would I set that up? Hey, you too, bro. You too. Hope you've been well. Alright, CH2. Bang. 1, 2, and CH3. Yep.
So I'm going to start with the CH carbon. So we have a carbon attached to 2 methyl groups. You know what? We could draw it this way. I'm going to put the second methyl group here. And then this hydrogen, I'm going to put it on top. Now that carbon is attached to a CH. So that's a carbon with a hydrogen, pentane. Try this one. Actually, let's change it.
CH3. What?
Go ahead and work on that. What the frick? Bang. CH2, CH3, CH2, CH3. Done. Alright, CH. Bang, next one. CH2, bang. CH2. Western Australia. CH2. C. CH2. Right. C. CH. C. Example. So let's expand the structure first. Then part of it in the middle, the brain. What can we do here?
Oh, freaking double bonds. I'm an idiot.
So clearly we need more bonds. Notice that carbon has 2 bonds. So in order to get 4, we need to put a triple bond, not a double bond. And that is the right structure. So now let's count the longest chain.
Holy crap, that's tech. Alright, so 2, 3, 4, 5, 6, 7. On the third one, 1, 2, 3. On the third one, there is a right. 2, 3, 4, 5. On the fifth one, 2, 3, 4, 5. There's a CH3. Between between the 6th and the 7th, there's a triple bond. Should be done.
The longest chain has 7 carbon atoms.
I can't able to understand whatever you said. Alright, bro.
3, 4, 5.
Just
6,
watch.
7.
Just watch and learn, man. Just watch
Now
and
we're
learn.
going with
Wait, let me.
alkynes. We need to draw
Hold on.
a straight structure because alkynes tend to be straight. So I'm going to start with this first. So this is carbon 1, carbon 2, carbon 3, and then we're going to bend it. So this is going to be carbon 4, carbon 5, carbon 6, carbon 7. The skeletal structure is typically drawn that way.
Mic
when
is
dealing with
very low.
alkynes. Now, on carbon 3,
Alright.
we do have a methyl group, so we can put that here. In fact, we don't need to show the methyl group, we could just leave it as a line. And carbon 5.
Alright, is this better? Is this better? Is this better?
Like this. So this is going to be the anther. So right here. So this is going to be carbon 4, carbon 5, carbon 6, carbon 7. You got a methyl group on 3 and an ethyl on 5. So now you know how to convert a the skeletal structure is typically drawn that way. Now, on carbon 3, we do have a methyl group, so we put that here. In fact, we don't need to show the methyl group, just leave that line. And carbon 5.
Alright, is this better? Is this better? Okay, I think that's a bit better. I think that's a bit better, to be honest. Alright.
That structure into the skeletal structure. Now feel free to check the links in the description section below for those of you who are more.
Okay, hopefully this is good. I'm in Western Australia, by the way. I missed it. Hopefully this is good. Hopefully this is good.
In this video, we're gonna right here.
Okay. 3 CH. Yeah. 4 5. Yeah.
We got a methyl group on 3 and an ethyl on 5.
Perfect.
So now you know how to convert a condensed structure into a skeletal structure. This video is for those of you who are thinking about. In this video, we're going to focus on functional groups. So this is the first functional group we need to be familiar with, and this is an alkane.
Okay, this is important. This is very important to understand organic chemistry. Functional groups. Let's get it.
An alkane is an hydrocarbon that only contains single carbon hydrogen bonds. It doesn't have any double bonds.
Alkane.
Just all single bonds. This particular alkane is known as pentane
Contains.
because it has 5 carbons.
It contains only single bonds. So this is like the building block of organic chemistry.
Methane has 1 carbon, so this is methane.
Alright.
Ethane has 2 carbons.
Yep, makes sense.
Propane has 3. Carbon has 8. Nonane has 9. It's represented by this one.
So it's methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane.
So this particular molecule
Nice.
is known as
An alkene.
the functional group. So anytime you see a carbon-carbon double bond, it has an alkene functional group. Now this particular alkene has 4 carbons, and the double bond is between carbons 2 and 3. So you pick the smaller of the 2 numbers, and so you call it 2-butene. Now what about this example? What if we have a carbon-carbon triple bond?
Alkyne.
In this case, this is known as an alkyne.
Oh, I'm tough. I'm tough. I'm tough.
So that's the function. And the particular name for this molecule is 2-butyl. It has the suffix "ine". Now, if you want to draw the line structure for that molecule, it looks like this.
Alkyne.
So there's 4 carbons. This is carbon 1, 2, 3, and 4.
What?
2, 3, 3, and 4. Now, what functional group is represented by these molecules?
These are carbon ring
These
structures.
are known as cycloalkanes.
These are cycler.
It's an alkane because
Okay,
has
it's,
single bonds.
it only has single bonds. Right.
And it's cyclic.
This is cyclopentane.
Now, the first one is known as
Nice.
cyclopentane, because as you can see, there's 5 carbons, and the second one has 6 carbons, and so it's called cyclohexane. Now, what about this one? Let's say if we have a cyclic structure with alternating double bonds. What functional group do we have here? This is known as
Cycloalkene.
aromatic ring.
Oh, hold on now. Something interesting happened. Something's happening. All right, it's got alternating. Okay. Alternating double bonds equals aromatic ring.
Now, this particular aromatic ring has a special name called benzene.
Ooh,
This
benzene unlocked.
typical organic chemistry groups.
We just unlocked benzene in this bit.
Now, what about this one? What if you see a halogen attached to a hydrocarbon? So the functional group for this molecule is known as an
Ooh,
halide.
benzene unlocked.
Now, you can also call it a haloalkane. It's another way to describe it. And so it has the functional group Rx, where R is the hydrocarbon chain and X is the halogen peak.
Wait, give me a second. Wait, relearn this.
6 carbons. And so it's called cyclohexane. And so it has the functional group X, where R is the hydrocarbon. Now, what about this one? Let's say if we have a cyclic structure with alternating double bonds. What functional group do we have here? This is known as an aromatic ring. Now, this particular aromatic ring has a special name called benzene. So you'll see this a lot, but
Okay, that's a halogen.
what if you see a halogen attached to a hydrocarbon, which is the name for it? So the functional group for this molecule is known as an alkyl halide.
Alkyl
Now, you
halide.
can also call it a haloalkane. It's another way to describe it. And so it has the functional group Rx, where R is the hydrocarbon chain and X is the halogen. It could be chlorine, X could be bromine, as we saw in this example. It could be fluorine or iodine. So that's an alkyl halide. So next up, we have in fluorine, X could be bromine, as we saw in this example. It could be fluorine or iodine. So that's an alkyl halide. So next up, we have an ether.
Ooh, ether. I like that.
An ether is basically an oxygen attached to 2 R groups. The R groups could be methyl groups, ethyl groups, and so forth. So we have 2 methyl groups.
Oh, so
attached
ether is
to
the
this.
cock.
So it's called dimethyl ether. Ethers are polar due to the oxygen. And as long as you don't have too many hydrocarbons attached to it, if the hydrocarbon chain is not so big, it's going to be a relatively polar molecule.
Okay, I think I understand that. Alright, what's next?
What about this
An
one?
ester, maybe?
What type of functional group
Oh, it's an alcohol.
do we have here?
Easy.
So if you see
Hold,
an
that's
O group attached
that's
to it,
primary.
this is known as an alcohol.
That's secondary.
So for this example, we have 4 carbons and the OH group is on carbon 1, so this is called 1-butanol. For the second example, the OH group is on carbon 2, so that's going to be called 2-butanol.
Butanol. Yeah, makes
So if
sense.
you see an OH group attached to a hydrocarbon chain, it's an alkyl. So what about this molecule? What type of functional group does it represent?
This is a carboxyl. No, not a carboxyl. But it's a. Oh, what am I saying, bro? It's a ketone. It's a ketone. Wait. Yeah, it's a ketone. It's a ketone. Yes, sir. I like this right here.
Aaron. 2 with this one.
Yep. Ketone versus aldehyde.
So the first one is the formula RCO and then some other R group. If you see that, this is a ketone. The oxygen looks like this. Now this particular ketone has 5 carbon atoms, and this is known as a carbonyl group.
See, I knew it, bro.
So that ketone is called 2-pentanone. On the bottom,
Yeah, that makes
we
sense.
have an aldehyde. And if you see this RCHO, that's the functional group for an aldehyde. And this is for a ketone. So this particular aldehyde has a
CHO.
total of 6 carbon atoms. And the aldehyde functional group will always be at the end. So you
I'm feeling sleepy. I can't lie.
So this is simply hexanal. So instead of a OL, you can see it has the suffix.
Yo, bro.
So that's an aldehyde. So make sure
Oh, I'm so sleepy.
an aldehyde from a ketone. An aldehyde has the carbonyl functional group at the end of the chain. A ketone has the carbonyl group somewhere in the middle of the chain, and that distinguishes the two. Now, for those of you who might be studying,
No free sponsorship, baby.
so what about this one? RCOOH. What functional group do you think
Carboxylic acid.
this represents? So this is known as a carboxylic acid. So that's another functional group we need to be familiar with. And in this example, we have a total of 6 carbons. And so this is going to be called hexanoic acid. So the suffix for carboxylic acid is oic. Now what about this one? What functional group is represented by this molecule? So if you see RCOOR, what functional group do we have here? So this is represented by something called an ester. Now to name it, this portion here, this is the ethanoate part. That includes the carbon with the 2 oxygens. And so it's ethanoate because there's 2 carbons here. And the right side has a methyl group. So when you name it, you need to put it, it needs to name this one first. So it's methyl ethanoate.
Come on, lock in.
So that's
Ester.
how you name an ester. So the OA part comes last.
Oh, wait, hold on, bro.
Comes last. And so it's ethanoate because there's 2 carbons here. And the right side, wait, suffix presented by this molecule. So if you see RCOO, what functional group do we have here? So this is represented by something called an ester. Now to name it, this portion here, this is the ethanoate part. That includes the carbon with the 2 oxygens. And so it's ethanoate because there's 2 carbons here. And the right side has a methyl group. So when you name it, you need to put it, needs to name this one first. So it's methyl ethanoate. And so that's how you can name it.
So you add a carboxylic acid plus an alcohol, and you get an ester. Carboxylic acid. I forgot. Yeah, bro. Wait, time out. What? Plus. Yeah, but I don't get that. There would be one too many. There would be one too many oxygens. Oh god, no. It's over for me, bro. Dude, I need my high school notes, bro. I used to be the goat at organic chemistry, but then I fell off after the great
OE comes last.
the great unemployment shift.
Now the next functional group we need to go over
Ew. Oh wait.
is an amine.
Good.
And so
I'm in.
it has hydrogen bonding, like an alcohol or a carboxylic acid. And let me give you some examples.
So okay, so
So this is known
amin
as
is 2 H's. Amide
amine.
is
That's the
NH3.
common name for it. And here, I think this is
Yes, sir.
name for CH3, CH2, NH2. So we have an ethyl group attached to an amine functional group. So
Yo, bruh.
and so the common names are very straightforward. Now, what if there's a carbonyl group attached to
Oh no, that's an amide. That's an amide. That has to be an amide.
what is the functional group called? So you can write this as RCONH2. If you see that, it's the same as what we see above. So this is known as an amide
What's NH3 then?
or an amide. Now, this particular group, well, let's use an example to name it. How can we name this molecule?
Hey, let me try real quick. Yo, bro. Alright. 1, 2, 3, 4, 5, 5. Pent. 2 pentamide, 2 pentanamide, 2 pentanamide, 2 pentanamide, 2 pentamide.
We have a total of 4 carbon atoms. And so to name it,
4.
this is going to
What?
be butanol.
What? 1, 2, 3, 4, 5. Am I tripping?
So instead of saying butane, take off the E.
Oh,
add amide
wait.
at the end.
Ah. Okay, here's where I went wrong, right? I thought this here was a carbon, but it's not a carbon because there's an amide. There's an amine group attached to it, right? So it's not pent, it's butenamide, and there's no number. Why, you may ask, that there's no number? Good question. Because if you put a number either way, like you only put a number so you can get the order of which carbon, right? So it's like this could be 1, but this could also be 1, right? It doesn't matter because since 4 is an even number, like if it's here, it's the same thing, right? So the 2 doesn't matter. Big brain.
The next one is
Nitride.
so if you see
Nitrile?
a triple bond between a carbon and a nitrogen atom, you have a nitrile functional group.
I've never heard of that before. Nice.
Here's a good example of one. CH3C triple bond N. So we have a total of 2 carbon atoms. And so this is going to be called ethane nitride. So here's the next functional group. What functional group do we have here?
It looks like stuff.
This is known as an acid and hydride. The common name for this molecule is known as acetic and hydride. When you see the word acetic, it's similar to ethane. It has 2 carbons.
Wait, I missed it.
It has 2 carbons.
Acetic equals to carbons. Okay, I didn't know that.
Is an acid chloride.
Acid chloride. Okay.
This is also known as
Acetic.
acetyl
Acid.
chloride. Now you can have a different halogen attached to it.
Halogen.
You can have a bromine atom attached to it. So this would be called an acid
Acetyl.
bromide instead. Or acetyl. Now what about this example? Let's say if we have an SH group. And how is it similar to an OH group?
So
Now we know if we have an OH group, it's an alcohol. What if we have an SH group?
the sulfonal.
This is called a thiol.
What?
Now what do you think these are?
Thiols?
Anytime you hear, if you see a sulfur attached to,
A carbon?
let's say, a hydrocarbon,
Hydrocarbon.
the word thiol will be present. So here's some other examples.
2 girls in their cut.
On the right, this is known as an ether. So what do you think the functional group on the left is going to be called? This is known as
Thiol.
thiol ether.
Thioether. Oh my gosh, that's tough.
Now on the right, at the bottom, this is called an ester. On the left, this is known as a thioester. So see the similarities. Alcohol, thiol.
Thio. Why did this?
Have ester
Oh.
and then thioester. So if you see an oxygen being replaced with a sulfur atom, add the prefix thio.
Okay. Wait, let me write that down. Write that down. Okay. Note. If you see a oxygen replaced with a put becomes thio.
They have some sort of thio on it. this functional group. So what if we have an alcohol and an alkene next to each other? So this is going to be called an enol. Think of the word "ene" for alkene and "ol" for alcohol. So if you see those two together, this is called an
Alcohol plus alkene equals enol. Ewok.
So here's another one.
Coffee
Let's
spells.
say it's
Ewok.
nitrogen with two bond groups, and it's next to a double bond. So a carbon with a nitrogen
Anal.
is an amine,
Yeah, but clip that.
and a double bond is an alkene. So if we combine these two, we get something called an enamine or enamine. And so that's the functional group that corresponds to this one. Now, if you see a carbon double bonded to a nitrogen atom, this is known as an imine.
Carbon double
Now, there's a
bonded.
few more examples I want to go. Now, there's a few more examples I want to go over. What do you think this is called? Have you ever seen this molecule before? In other words, H2O2. H2O2.
Hydrogen peroxide.
What we have here is
An
organic peroxide. So if you see two oxygens attached to each other, it's a peroxide. If they're attached to each other through a single bond. Now what do you think this is called? And let me compare it to this molecule. So this molecule here, you know,
Wait, stop. Alright, okay. What is this? Okay, COOH. That's an acid, carboxylic acid. But it's a carboxylic peroxic acid. Yeah. Where's lost the plot, bro? That is my carboxylic acid.
it's a carboxylic acid.
Yep, I know that.
And here we have a peroxide.
Carboxylic peroxide. Peroxylic acid.
This entire molecule is called.
Peroxylic acid. That's my
This
guess.
is known as a peroxy acid. Very similar to a carboxylic acid with a peroxide functional group. So we're
Peroxy acid.
Peroxy acid.
Makes sense.
We're going to go over one more group. You might see this, but you may not. Or you may see an orgo too. This is known as a nitro group.
Nitro.
You might not see this in orgo 1, but it's definitely in organic chem 2. So I'm going to stop here. There's some other functional groups to know, but these are some very common ones. Actually, there are some other ones you need to know.
Alright, bro.
I wouldn't really consider them functional groups, but you need to know the names of it.
Let's see.
So this is called a carbocation. And if you have, let's say, an odd number
Carbo.
of electrons, this is known as a radical. And
Carbocation.
this is a carb anion. And this species is neutral, but if you see it, it's called a carbene. So I'm going to stop here.
Bro, I can't even see that. What the hell is that?
So I'm going to stop here. So that's it for this video. Thanks for watching.
I've never seen that before. Ooh. Two girls in the club. Which one to choose? Fell in love with you. Fell in love with two girls in my club. Which one to choose? Fell in love with you. Fell in love with you. Alright.
In this video, we're going to talk about
55 minutes. Oh my god. Alright. I'm gonna watch this video. I don't know if I'm gonna watch it on stream. Actually, I have to speed on it. Alright, so I'm gonna watch this video, right? Then I'm going to not write down too much notes, but I'm just doing it to familiarize myself with this content, because I'm learning organic chemistry for one reason. If you don't know, right? I'm learning organic chemistry so I can master GAMSAT and get into medicine. That's the goal. That is the goal. All right. So I've got to be smart here. Yeah, I've got to choose. I've got to pick my battles. And this battle with the 55-minute video, it's just not worth it. It's just not worth it at all. I don't know what to do. All right. So what I'm gonna do is I'm going to just listen to all this.
Functional groups, in addition to the regular ones as well. So the first one we're going to talk about is a very common one. This is an alkane. It's a hydrocarbon. It's saturated. It's filled with hydrogen. And has a form of C5H12. This is pentane. This is a cycloalkane because it forms a cyclic shape. This is an unsaturated alkane. It's not filled with hydrogen. The chemical formula for cyclopentane is C5H10. Notice that it has 2 hydrogen atoms less than pentane. So the IHE, the index of hydrogen efficiency, is 1. Anytime you have a ring, the IHE will be 1. This is called a bicycloalkane. Bi needs 2, since we have 2 rings. Now, because we have 2 rings, the IHD is 2. In addition to cycloalkanes, alkenes are also unsaturated hydrocarbons. For every double bond, the IHD will be 1. So that's an alkene. This is a diene, or you can also call it an alkadiene. Diene needs 2, since we have 2 double bonds. The IHD for this molecule is 2. This is also known as a conjugated diene. Whenever you have alternated double, single, and double bonds, you have what's known as a conjugated diene. This here is an alkatriene. It's also a conjugated diene. A conjugated alkene. Now, sometimes you'll have double bonds right next to each other. This is known as accumulated diene, which also has a special name, alene. If the double bonds are far apart from each other, where they're not conjugated, this is simply known as an isolated diene.
Wait, reload that.
This is known as accumulated diene, which also has a special name, alene. If the double bonds are far apart from each other, where they're not conjugated, this is simply known as an isolated.
Okay. Why would I have an IH? Why would they have an IHD at 1 though? Yo, bro, I'm trying to study right now, bro. Stop distracting me. IHD. Index of hydrogen deficiency. Bro, it's my time. It's my study timer. You idiot. Idiot boy. Alright, come on. Anyways. Distracting me from the grind. Streamer of the minute. Yo guys, alright guys, make sure also vote for me for streamer of the year for the streamer awards. Thank you.
Now, whenever you have a triple bond, you're dealing with an alkyne. If the triple bond is in the middle of the chain, it's an internal alkyne. If it's at the end of the chain, it's called a terminal alkyne. The IHD, the index of hydrogen efficiency for a triple bond, is 2.
Wait. Okay, so pi bonds are double or okay. higher IHD value indicates more unsaturation. That makes sense. Because the more double bonds, triple bonds you have, the more carbons you can add to that structure. Indubitably.
This is benzene. The functional group is an
Aromatic ring.
also known as an arene. The IHD, look at the IHD for benzene is. We have a ring, 3 double bonds, that gives us IHD of 4. So if we were to compare that to hexane, which has 6 carbons, 14 hydrogens, we can determine the number of hydrogens on this. Every time you have an IHD of 1, that means you have 2 less hydrogen atoms than the number of hydrogen atoms in a saturated alkane. So the maximum number of hydrogen atoms that could be on 6 carbons is 14. With an IHD of 4, 4 times 2 is 8. 14 minus 8 is 6. So the chemical formula for benzene is C6H6.
Oh, okay. Okay, so
Now, when benzene
number of hydrogens
is on
equals
a very long carbon chain, it's going to become a substituent.
2
As a substituent, it's called
times IHD.
In organic
Right.
chemistry too, you're going to learn about this intermediate. This is called the benzyne intermediate, and it's typically found in nucleophilic aromatic substitution reactions.
So normal.
So think of a benzene with an alkyne functional group inside of it. So it's called benzyne. Now, let's talk about alcohols. So this is an alcohol. Particularly, it's a
Let's
primary
talk about
alcohol
alcohols.
because the OH group is on the primary carbon.
The
reason why
lock.
this carbon is primary is because it's attached to one other carbon atom. Secondary carbons are attached to two carbon atoms.
Alright.
Tertiary carbon atoms are attached
Break
to
time.
carbon atoms.
Let's
So
continue
that's a
watching
primary
this.
alcohol. This is known as a diol, particularly a cis diol. So the word diol means two. You have 2 hydroxyl groups. This is called a thiol. Whenever you see the prefix diol, think of sulfur. Now, Gen Chem, you know OH minus. This is hydroxide. In organic chemistry, you're going to see something similar. And this is called, it's like a strong base, just like hydroxide, but it's called alkoxide. So instead of OH, you have this OR.
What? That makes no sense. Hydroxide. Okay. Oh, is it a minus? No bond? Bro, draw it a bit more clear next time, buddy. Alkoxide.
But both are strong bases. Now, if OH
Thi-
is hydroxide and
Dioxide.
OR is alkoxide, what do you
Thioxide. Thicoxide.
think are negatives?
Equals
You deserve $20 if you can guess the right answer.
thicoxide.
This is called a thiolate ion.
Bro, what?
I'll be very surprised if you got that right.
Thiolate.
So that's the thiolate ion. This is an ether. It's abbreviated.
Thiolate. Ion.
This is an ether.
Yep.
It's abbreviated ROR.
What was the other one?
What do you think this is? If we replace the oxygen with the sulfur, and we get the group RSR. What is that?
Hold on. Bro, do I have to sign up to his stupid course to watch this? Wait, maybe I don't.
This video is for those of you who are studying for the first exam of organic chemistry. And it covers topics typically taught in the first 4 chapters of a typical organic chemistry textbook, such as functional groups, drawn Lewis structures, hybridization, sigma pi bonds. This is called a thioether. It's also called a sulfide,
Wait, time out.
an organic sulfide.
Time out. Oh, Dude, that's the best CO2 of all time.
Now, what if there's two oxygen atoms?
Fire is it? Or
So this is no longer called an ether.
it's a peroxide.
Different class of
It's a
compounds.
peroxide, buddy.
It's called an organic
Peroxide.
It's highly reactive. Now, what if we replace the two oxygen atoms with two sulfur atoms? What do we have now? This is called a disulfide. So this is a sulfide, this is a disulfide, or an organic disulfide. Now, typically, you'll see these disulfide bridges whenever you have the oxidation of the thiol group. So cysteine is the amino acid of the thiol group. When two cysteine molecules get oxidized, they will form a disulfide bridge. So typically, you'll encounter that function group in maybe biochemistry when you go over amino acids.
Ah, yes. I've seen this so many times.
This is H2O2.
That's hydrogen peroxide.
Hydrogen peroxide, along with the organic peroxides, they're typically associated with radical reactions.
Oh my, disulfide bridge. Yes, I've seen this before.
Now, what if we have a 3-atom ring with oxygen?
I've never seen that before.
This is called an epoxide. It looks like an ether, but it's in a ring instead. If that is an epoxide, what is this?
Hexoxide.
So this is called an arene oxide, also known as benzene oxide. Now, instead of a 3-atom ring, you can have an oxygen in a 4-atom ring. 3 carbons and 1 oxygen. If you see this, this is called oxetane. Now, sometimes you'll see this where there's an oxygen. There's 2 oxygen atoms in a ring. So we have 4 carbon atoms, 2 oxygen atoms. This is called an oxane, specifically a dioxane. Now, the oxygens, they're 1,4 apart. Let's say this is atom 1, 2, 3, 4. So this is specifically called
1,4.
Dioxane.
Diamine.
If we replace the oxygen with the sulfur in the epoxide functional group?
Dioxide. Dioxide? Does that make
This is
sense?
called thiirane.
Thiirane.
Special prefix.
What about Palestine? My bad. My bad.
Now, this is another special class of cyclic ethers
I'm not trying to be political.
that I want to discuss. If you're taking organic chemistry 1, you're going to see it when you go over
What the?
SN1, SN2 reactions.
Okay,
So this is called a crown ether.
That's gonna be tough.
Specifically, this is called a 12 crown 4 ether. There are 12 atoms in total, 4 of which are atoms, and 12 times 4, the remaining 8 are part atoms. Now, you do have other categories of this type of ether. What I'm going to draw is a 15 crown 5 ether.
I already said it.
So that's the 15 crown 5 ether. There are 15 atoms in total, and 5 oxygen atoms. The 12 crown 4 ether is very useful for solvating lithium ions. The 15 crown 5 ether is bigger. It can solvate a bigger ion, in this case the sodium ion. And the 18 crown 6 ether is used to solvate the potassium ion. So now let's move on to the next one. Let's talk about this functional group. So we know this is an aldehyde. Anytime you see a CHO functional group, you know we deal with an aldehyde. This here is a ketone. The aldehyde has 1 R group. The ketone has 2 R groups. The aldehyde has the hydrogen as a carbonyl functional group. So here's a question for you. If this is an aldehyde, what is that?
Wait. I know. I know what it is. Aldehyde plus alkene. Aldehyde plus alkene equals.
And if this is a ketone, what is this?
Ketene.
So this is still an aldehyde. It also has a special name, an alpha beta unsaturated aldehyde. This is the alpha carbon, that's the beta carbon. The double bonds between the alpha beta carbon, so it's an alpha beta unsaturated aldehyde. But it also has another name. It's known as an enol. And it makes sense because here we have an aldehyde and we have an alkene. Whenever you're naming an aldehyde, it ends in al. So for instance, this 4-carbon aldehyde is called butanol. So this suffix al. That's how you're dealing with aldehyde. Whereas if you're naming an alkene, this is 1-butene. So ene is for the alkene. Here we have an alkene and an aldehyde, so it's called enol. So if that's the case, what do you call this one?
Wait, enone.
With an alkene, this is called an enol. Alkene plus
So that.
ketone. Enol. It's also an alpha beta unsaturated ketone. Now, if this is an aldehyde, what do you call this? Let's say we replace the oxygen with a sulfur. What do you call it now? So while you're thinking of that one, I'm gonna write up a few more.
Eth.
If we replace the oxygen with a sulfur, what do you call it now? So while you're thinking of that one, I'm gonna write up a few more. Go ahead and identify the functional groups, if you know what they are. So on the left, instead of an aldehyde, what we have is a thiol. To think of, so if you recall, a thiol is an SH group. So like an alcohol, but there's thi and then ol, ol. Here, instead of the ol for thiol, since we have an aldehyde together, we have al instead. So thiol. They kind of sound similar, thiol. It's kind of hard to differentiate them, but the difference is an A instead of an O. If this is a ketone, what is that? This is called thioketone. So that one is easier to remember. Now, if we replace the carbon with a sulfur, but keep the oxygen there, what do we have now? So it's not a thioketone, it's something else entirely. This is called a sulfoxide. And if we have 2 double bonded oxygens on that sulfur,
Disulfoxide.
this becomes a
Di-
sulfone. Not
Ooh.
cell phone, but sulfone.
Okay.
Now, we know this is an alcohol. Particularly, this is a secondary alcohol because the OH group is on a carbon that's attached to 2 other carbons. So that makes it a secondary alcohol. This is an amine. Now, it's not a secondary amine, it's actually a primary amine. With amines, it's determined differently. For alcohols, they're always attached to 1 carbon atom. So the type of alcohol is determined by the type of carbon atom it's attached to. When you're dealing with amines, the nitrogen can be attached to 1 carbon, it can be attached to 2 carbons, it can be attached to 3 carbons.
Oh.
So the type of amine is not determined by the type of carbon it's attached to.
It's
It's
determined by.
determined by how many carbon atoms the nitrogen is attached to. So for instance, what type of amine is this? Is it primary, secondary, or tertiary?
Secondary. Nick.
This carbon atom is secondary. This one is primary. Do you say it's primary or secondary? So it doesn't make sense to look at the carbon atoms. In this case, you look at the number of carbon atoms attached to the nitrogen. So this would be a secondary amine. This is a primary amine because the nitrogen is only attached to 1 carbon atom. So the rules are different when you're looking at amines and alcohols, when you're determining if it's primary, secondary, or tertiary. Now, if this is an alcohol, what type of functional group do we have here if we put a double bond right next to it? And if this is an amine,
Alcohol plus E.
what is this? So while you figure that out, I'm going to draw
Wait,
some
stop.
pictures.
It's alcohol plus alkene is I swear it was enol. Yeah, it was enol.
If you know what the other ones are, feel free to mention it as well, each. If we can combine all with ene, we get an enol. Here we have an amine with an alkene. Combining those 2, we get enamine or enamine. Now, if you have a carbon double bonded to an N, instead of an enamine, this is called an imine or an imine. And this is called an oxide.
Oxime?
I will be very surprised if you got that one, if you've never seen it before. Now, this is very familiar. This is a carboxylic acid. Now, what happens if we replace the OH group with a chlorine? Or if we replace it with a bromine? What do we get? So this is called an acid chloride, and this is called an acid bromide. If you put them in water, it will generate a carboxylic acid. This will be replaced with the OH group. Now, what do you think this is? So instead of RCOOH, which is also RCO2H, you'll see this as RCO3H in orbital 1 and orbital 2.
It's a peroxide.
So if you remember this functional group, this was an organic peroxide. And here we have a carboxylic acid. So when you combine those two, you get a peroxy acid.
Peroxy acid.
So combine peroxide with carboxylic acid, peroxy acid. So anytime you see RCO3H, you're dealing with peroxy acid. Now, what's going to happen if we replace the oxygen with a sulfur atom? IO2. The acidic hydrogen is on the sulfur. The one on the right is also acidic. This is called a sulfonic acid. The R group acid. What if we replace both oxygen atoms of a carboxylic acid with a sulfur? What is that called? And what if we don't have double bond O on the sulfur? What if we just have that?
But they just be removing anything nowadays.
So this one, it's still similar to a carboxylic acid because oxygen and sulfur, they're in the same group. They're both chalcogens in group 6A. So it's still a carboxylic acid, but it's called dithio carboxylic acid because we have two sulfurs instead of one. You can also call it carbo dithioic acid. Now this one, it's still an acid. We have an OH group with attached to a sulfur. So this hydrogen is still relatively acidic. But this is called a sulfenic acid with an E. So instead of sulfonic acid, sulfenic acid. Now let's move on to esters. So this is an ester. Now what would you call a cyclic ester? What's the name for this type of functional group? A cyclic ester is known as a lactone. Now, what if we replace the OR group with an SR group? What do we get there? And what if we replace the double bonded oxygen with a sulfur? How does that change? So feel free to think about those in the meantime while I draw a few more functional groups. Both of these functional groups are known as thioesters. The one on the left, I've seen it referred to as thiol ester. And the one on the right, I've seen it referred to as thionoester. But they're different categories of thioesters. So if you see ester, just add a thio to it. Now, what do you think this is? Talking about esters, you know it's a type of ester. This is a sulfonic ester. Remember, if we replace the OR with an OH group, it becomes a sulfonic acid. So switching the OH with an OR group, it becomes a sulfonic ester. On the right, what we have here is called a phosphoester. Now, you'll typically encounter chemistry when you're studying DNA. Phosphoesters, they're found in DNA molecules. It's the bond that connects the phosphate group to the ribose sugar. Now let's move on. So what we have here is, as mentioned before, an amine, but particularly a primary amine, since the nitrogen only has one carbon attached to it. Now what happens if we add a carbonyl group to the amine? What does this become? So this is a familiar functional group. You know it to be an amide. Now what do you call a cyclic amide? Let's say it's part of our organic system. What is it now? Cyclic amides are known as lactones. So instead of lactones, which are cyclic esters, lactam, like think of amide, those are cyclic amides. Now looking at the amide function group, what happens if we replace this. This is called amity or amity. It's kind of similar to an imi, but instead of this being a hydrogen or an R group, which will make it an imi, the R group is an NH2. So that's the difference between an imine and amity. Now, what if we added another carbonyl group to the amide functional group? So where the nitrogen is in the middle. What is that? Notice that it looks very similar to this. So if it's an oxygen in the middle, this is called an anhydride. But if you have a nitrogen in the middle, this is called an imide. Very similar to an amide. But you just have two carbonyl groups instead of one. So that's an imide. Now let's compare the imide with other functional groups. I'm going to redraw. So that's the imide. What do you think this is?
Yo, come on.
So we have one carbonyl with two
Lock
nitrogen.
in.
That is
I will master organic chemistry. I will master organic chemistry.
so urea is a type of carbamide. If we were to replace the oxygen in urea with a sulfur group, this becomes thiourea. So urea is a carbamide, that's the function group for that. Now if we replace one of the NR2 groups with an OR, let's make this a different color. What does it become now? So why do you think about that? I'm gonna write this one. So what if we replace both NR2 groups with OR groups? So this is a carbamide. This one here is a carbamate with M ester. This part here, you can see, is the ester part. And this part looks like the amide part. So carbamate with an M, AM, ester. Now this is not.
Alright, boys. I've fallen asleep, so I'm finna end stream because I'm just too tired. Alright, stay tuned for next episode.